Perhaps the most terrifyingly fascinating aspects of our universe are black holes. These enigmatic objects in space, which resemble enormous garbage disposals or long, dark tunnels to nowhere, exert a gravitational pull that is so strong that nothing around can escape from being devoured, not even light. Almost never does what is put inside come out. Because of this, black holes are as devoid of light as the void and darkness around them, making them undetectable to the human sight. Scientists are aware of black holes even if they cannot see them because of how much their powerful gravitational pull affects the orbits of neighboring stars and plasma. The measurable radiation that is released while the gas is being drawn and becomes overheated is another indicator. In fact, it was the finding of the first black hole, Cygnus X1 in the constellation Cygnus, in 1964 that was made possible by these potent X-ray emissions. Black holes, as scientists are finding, are stranger than anything in science fiction. Time and space are distorted around black holes. A black hole's powerful gravitational attraction would progressively slow time and twist space if you were to fly close to one. You would be drawn in more and closer until you eventually joined an accretion disk of cosmic debris, planets, gases, stars, and dust racing inward toward the event horizon. As soon as you crossed this line, gravity would crush all attempts at escape, stretching or spaghettifying you as you fell toward the singularity at the black hole's center, an impossibly small point with an enormous mass where gravity and density theoretically approach infinity and space-time curves endlessly. In other words, you would be swallowed up and destroyed in a location that blatantly violates the known rules of physics. Black holes come in tiny, average, and giant sizes. The majority of black holes are of medium stellar mass. When a massive dying star, or supernova, bursts, the core that is left collapses under the force of gravity. It eventually shrinks towards the core, a tiny, impossibly dense singularity. Therefore, black holes are actually points of extremely compressed matter with oversized gravitational footprints rather than actual holes. While most stellar mass black holes are around 10 times as massive as the Sun, there are a few that are much larger, according to research. The largest black holes in the universe are supermassive ones, some of which have masses billions of times greater than our Sun. These massive and mind-boggling objects may have appeared soon after the Big Bang, and they are thought to exist at the core of every galaxy, even the smallest ones. Scientists are still unsure of how they form, though. Sagittarius A, also known as SGRA, a star with a mass of roughly 4 million suns, revolves around our own Milky Way galaxy. Additionally, stealth black holes have recently been found by researchers. These black holes generate fewer X-rays and seem to consume matter and gases more slowly, making them more difficult to detect. Additionally, according to astronomers, there are microscopic primordial black holes that were created just after the Big Bang. The smallest of these mini mysteries may be smaller than an atom, but with the mass of an asteroid, and the universe may be teeming with them. However, they have not yet been spotted. Too many black holes exist to count. It is estimated that the Milky Way galaxy alone contains between 10 million and 1 billion stellar mass black holes in addition to the supermassive SGRA in its center. It would be like trying to count sand grains with 100 billion galaxies out there, each with millions of stellar mass black holes and a core supermassive monster, not to mention other sorts being discovered. Things are devoured by black holes, who frequently spit them out. You can rest easy knowing that black holes are not roving the universe like ravenous wolves hunting planets and other celestial prey. Instead, these celestial animals eat everything that orbits too closely, like the unhappy star that scientists have seen over the past 10 years as it is swallowed up, the longest black hole meal ever recorded. The good news is that no known black holes are headed directly for Earth. However, just because it's unlikely that we'll be gobbled up doesn't mean we shouldn't be concerned. This is due to the fact that SGRA, and possibly other supermassive behemoths, periodically shoot planet-sized spitballs that may one day destroy us. How do spitballs escape the grip of a black hole? In reality, they are composed of material that coalesces into chunks as it escapes the accretion disk just before it reaches the point of no return. These large pieces, in the case of SGRA, are hurled into our galaxy at speeds of up to 20 million miles per hour. We can only hope that none ever flies too close to the solar system. Additionally, supermassive black holes give birth to stars and control the number of stars a galaxy receives. A recent finding demonstrates that gigantic black holes occasionally unloose enough material to produce complete new stars in a manner similar to how planet-sized debris are released from the accretion disk. Even more amazing, some even touch down in distant regions of space, far from their galaxy of birth. Additionally, a 2018 study published in the journal Nature contends that supermassive black holes not only produce new stars, but also regulate the number of stars in a galaxy by directly influencing the rate at which star production ceases. Strangely enough, star production slows down more swiftly in galaxies with smaller black holes at their centers. You could look into the abyss. 9 of the highest resolution telescopes in the world are combined to power the new Event Horizon telescope, which just captured images of the event horizons encircling 2 black holes for the first time. One is our own SGRA, and the other is a supermassive black hole 53 million light-years away at the center of the galaxy Messier 87. Astronomers were astounded by the latter's image, now known as Powahigh, in April 2019, but the photo session also sparked renewed interest in lingering issues about what black holes look like and the bizarre physical rules that power them. Yet another conundrum about black holes. A region of far-off space where supermassive black holes from many galaxies are aligned in the same direction has recently been discovered by astronomers in South Africa. In other words, their gas emissions all appear to be coordinated on purpose. Black holes that are up to 300 million light-years apart appear to be working together, but current theories cannot explain why. In fact, according to academics, there is only one way it is feasible if these black holes are spinning in the same direction, which may have happened during galaxy formation in the early universe. Watch out! Black holes most likely exist in our Milky Way. Given how hazardous a black hole is, the logical next query is Earth currently in imminent danger of being sucked in? Although there is likely a large supermassive black hole hiding in the center of our galaxy, astronomers say the answer is no. Fortunately, we are around 2/3 of the way from this monster's center in relation to the rest of our galaxy, so we are far enough away to see its impacts from a distance. For instance, according to the European Space Agency, it is surrounded by gas that is astonishingly hot and is 4 million times more massive than our Sun. Black holes can be different diameters. According to NASA, there are at least 3 different kinds of black holes, ranging from tiny squeakers to those that predominate at the galactic core. The smallest black holes are called primordial black holes, and they can be as big as mountains or as little as an atom. The most prevalent kind, stellar black holes, are up to 20 times as massive as our own Sun and are probably scattered throughout the Milky Way in large numbers. Then there are the enormous supermassive black holes, which are found in the centers of galaxies. Each of them is 1 million times as huge as the Sun. Investigations on the formation of these beasts continue. Strange things occasionally occur near black holes. The best example of this is when 2 people, let's name them Lucky and Unlucky, watch as one enters a black hole. Unlucky's time clock seems to be ticking slower and slower in Lucky's eyes. According to Einstein's theory of general relativity, time is impacted by speed when traveling at extremely high speeds that are close to light. Unlucky's time appears to be moving more slowly because of the black hole's extreme warping of time and space. Unlucky's clock, however, appears to be running normally while Lucky's appears to be moving quickly. Wormholes may or may not exist. What transpires if someone enters a black hole is a common theme in science fiction. Some individuals think that these objects represent a kind of wormhole to other regions of the universe, enabling travel at speeds faster than the speed of light. We still have a lot to learn about physics, as this Smithsonian Magazine article notes, so anything is possible. According to Avi Loeb of the Harvard-Smithsonian Center for Astrophysics, we do not know of the full zoo of conceivable spacetime structures that could allow wormholes, as we do not yet have a theory that consistently combines general relativity with quantum mechanics. This is all for today. Thank you for staying with us. Don't forget to like and subscribe our channel. See you soon.